Hi, and welcome back to the Anatomy of Synergy. In the last video, we started learning about synergy data types, beginning with the alpha type. We'll continue by exploring the decimal data type. Let's get started. The decimal data type is one way to store numbers in a synergy program. A decimal value is a signed whole number. Just like alpha data, decimal data is stored using ASCII characters, making it easy for humans to read the value of decimal data. While alpha data can consist of any ASCII character, decimal data can only consist of the 10 digits and the lowercase letters P through Y. These letters are for storage purposes only. Synergy will use the letters in place of the rightmost digit in a number to indicate that the number is negative. For instance, the number -100 is stored as 10P, and -4321 is 432Q. However, you don't really need this level of detail. The important thing is that you don't have to account for a negative sign when you designate the size of a decimal field. You can define a decimal field in a record with the letter D. As with alpha data, the number after the letter determines the size of the field in bytes. Since each byte in a decimal field stores a single digit, the number of bytes in a decimal field is also the maximum number of significant digits the field can have. For example, if we defined a D4 field, it could have 4 significant digits, meaning that its value can range from -9,999 to +9,999. A decimal field can have a size as small as 1 or as huge as 28. For now, let's use a smaller size. We can also use an asterisk and an initial value to automatically determine the size of the decimal field. In this case, the field would have a size of 4. Now that we've defined some decimal fields, let's use them in our program. We'll set a breakpoint so we can see this code in action. Here is the program before that line runs. Notice that the first decimal field has a value of 0 because we didn't give it an initial value. We gave the second field a 4-digit initial value, but didn't specify a size, so it was given the size of 4. Now let's run the code. The program added 1000 to the second field and stored the result in the first field. Since the first field had a size of 5, it was big enough to hold the result. But what if it wasn't big enough? Let's try this again. Since the field is now only 4 digits long, it can't hold the value of 10,876. It only holds the last 4 digits, 0876. If you want to do arithmetic with decimal values, make sure you put the result in a field that's big enough to hold it. So far, we've used the decimal data type to store values used for calculations. But decimal data can also be used to store other values represented by digits. Let's use a decimal field to store a phone number. We can use something called an overlay field to designate the area code. This is just a normal D3 decimal field, but the @phone number says that the field starts in the same location as the phone number field. If we look at this in the debugger, we see that both phone number and area code are treated as separate decimal fields. We can also use overlay fields for other data types. Let's change phone number to an alpha field. Since the area code doesn't start at the first byte of phone number anymore, we have to change the overlay to start 1 byte later. Back in the debugger, we see that the area code is still a decimal value, even though the phone number is now an alpha. Since both data types are stored using ASCII values, we can treat digits as either alpha or decimal data, depending on how we want to use them. This concludes our introduction to decimal data. We've learned the basics of the decimal data type, how it can be used to store all types of data made up of numeric digits, how to do basic calculations with decimal data, and how to use overlay fields in records. In our next video, we'll explore the implied decimal data type.